today I'll be presenting some key learnings from our demo blog project, as well as my PhD research on digital building logbooks, DBLs, but in the context of energy renovations, and more specifically on the importance of creating interoperable digital data sources for the DBL to produce and generate accurate renovation advice. When we talk about energy renovation in the context of homes, homeowners are often faced with several challenges and barriers, among which I'd like to stress on two macro groups, the socio-technical and the financial barriers. On the former, it was identified that sustainable technologies are often misaligned with the capabilities and the needs of the end users. Two main causes I'd like to highlight here is the clear lack of information and support provided to the end user before, during, and after the renovation works, as well as the undefined process to designate responsible stakeholders to identify, plan, and deliver these works. On financial barriers, a recurring challenge is to provide homeowners with the viable and compelling business case to invest in energy renovations. Contributing reasons include the lack of funding schemes and opportunities, and also the information about them, as well as a limited to no provision of a clear overview of the profitability of the energy renovation. But what if homeowners can easily track the changing statuses of their homes through the comforts of their screens? And what if the same platform can also provide insights on the energy performance of the home, identify priority renovation activities with an overview of the costs, and inform homeowners of their renovation obligations to ensure that their homes meet the minimum standards over the years? What you saw on the screen is the Woningpas, which is an example of a DBL that's active in the Flemish region of Belgium. As was earlier established, the DBL is defined as a common repository for all data and information relevant to a single building. Why? To address issues such as data loss and data unavailability that's caused by the inconsistent way of data collection that's practiced by the various stakeholders across the AECO sectors. A DBL therefore records and traces every change made to a building across its life cycle, including but not limited to changes in ownership, tenure or use, maintenance, and refurbishments. But as we've seen from the Woningpas example, the DBL has evolved from the mere common data repository to a digital processor of building data, providing extensive information and analysis on the homes. Now, ideally, the DBL can also be seen as a simple user-centric solution that enables all homeowners to easily identify renovation needs of their homes and address them accordingly. How this works is that once all the necessary data is stored or linked to the DBL, the services built around the DBL will then process the data to provide useful and relevant information that is needed to, for instance, design renovation roadmaps, plan the costs and finances for the renovation activities, as well as monitor and assess the decarbonization progress of their home. And these services are what we call functionalities. From studying 31 existing DBL initiatives at the exploratory stage, we were able to identify 21 common functionalities. And these functionalities can be further categorized to serve four main purposes, which are information storage, quality and performance monitoring, building assessments and calculations, as well as integration with external sources and tools. So, what kind of data do we need to store in the DBL to generate more accurate energy renovation advice for a home? For that, I would like to direct your attention to this little part. As a starting point, the renovation wave identifies the EPCs, the building renovation passport, smart readiness indicators, and levels as priority building information. The EPCs are intended to provide tenants and buyers with reliable information on the energy performance of the home. And to generate an EPC, lots and lots of data is needed, including those from documents such as technical plans, HVAC guides, survey reports, and in certain cases, data from other digital tools such as BIM and GIS, as well as digital twins in the future. The Building Renovation Passport, or the BRP, on the other hand, is essentially an evolution of the EPC. Essentially, it's a user-friendly document that outlines the long-term, step-by-step renovation roadmap for a building to assist homeowners when planning staged deep renovations. When stored in the DBL, the type of information that can evolve over time can range from the available financing options for renovation projects, such as green loans and government incentives, to energy bills, smart meter data, equipment maintenance requirements, as well as insurance, property plans, and obligations. The added data of the smart readiness indicators, or the SRIs, which assess how smart a building is in terms of responding to the needs of the occupants. And levels, which is a European framework for core sustainability indicators that assess and report on the performance of the building, will not only ensure that quality data is provided to the DBL, but they can also support the EPC and BRP data to provide even more informed advice on sustainable and smart building renovations. In practice, however, it's observed that what constitute as priority documents really depend very much on the context and goals on which a DBL is developed. Going back to our example here, the Woningpas is a public initiative that's owned and developed by 3 agencies of the Flemish government as part of the implementation trajectory of the renovation wave and the regional decree on building passports. Linking the Woningpas to all available government data is thus central, which is done so with APIs. And this way, the Woningpas is not only automatically fed with an abundance of data, which is verified, but it's also why the DBL can also be made freely available to the homeowners of all 4 million individual housings in Flanders. As such, information categories currently offered by Woningpas that make use of available government data include cadastral information such as soil characterization, water and sewage, and flood sensitivity, as well as certificates such as the EPC and the Flemish EPB, building permits and mobility assessments. And with the added data and information manually stored in the DBL and data from other monitoring services such as meter data and potentially digital twins, the Woningpas can provide accurate analyses of the quality of the homes as well as the energy performance of it. And then subsequently suggest accurate overview of the priority renovation activities. So what does this mean for us? It can be observed that the interoperability of a DBL to its data sources highly depends on what constitutes as priority documents for the individual DBLs. But regardless, for a DBL to generate more accurate and effective strategies for a high-impact energy renovation, a wider spectrum of functionalities is needed. A wider spectrum of functionalities means a wider range of data fields, and a wider range of data fields means a wider range of data sources. Now, the digitization of the AECO sectors will lead to the collection of larger amounts of heterogeneous data through innovations such as the AI, real-time monitoring, and as we've been discussing today, the DTs. And increasing the interoperability between these available digital data sources is therefore essential in the context of energy renovations and the DBL. Yes, thank you.
Thank you very much, Suna.